Welcome to homework.
In this question, we are given a relation R defined on set of or subset of real number. So here means that two things that we are comparing with each other are sets, and two sets are related if they have the same cardinality. So cardinality is the same concept as the size of the set, but it also covers set that has infinite element. So think of a finite set as having its size as cardinality, right? So set of A we have cardinality 1, set of AB we have cardinality 2, and so on. But something that has infinite size like set here will be infinity, right? But there are many kind of infinity. So we have countably infinite and something like R, the real number, as uncountably infinite. And these two are different. The uncountably infinite will be larger, and you you may not find anything between them. So it's either countably infinite or uncountably infinite as far as you are concerned for this course. And yeah, that's how it works for cardinality. And show that first we have to show that R is equivalent relation. And this is easy, reflexive. Any set will relate to itself. Obvious. When set S relates to set T, so they have the same cardinality, then we must also have that T is related to S, right? Now for transitivity, suppose we have set A related to B and B related to C. We must also have A related to C. If you just think about the argument for each relation here, you're gonna see that their cardinality has to all be the same, right? And so we have the three conditions fulfilled. So R is equivalent relation. There's nothing complicated there. Now we are further asked to find equivalent class of these two sets. So the set of 0, 1, 2 and the integers, set of all integers. So plus minus 0. And the class here would mean all other set with the same cardinality with this set, right? So set of 1, 2, 3, its class, I will write it like this. Its class will be a set of sets. Okay, so element in here is set such that it has exactly 3 elements. So it has to be 3, otherwise its cardinality would be different, right? But as long as it has 3 elements, it doesn't matter what those are. Like they have to be real number, but it doesn't matter what real number we are looking for. So this is gonna be the set of all set like that, and they all made up this class, which in a sense it's easy to see why, right? Now things getting more complicated with set. So what kind of set will be in this equivalent class? Well, as far as we know that set is in there, obviously. But what other set? If we say that is a set S such that S is countably infinite. Infinite set, you may still not sure what are allowed or what doesn't allow. So I will show some example then. The class of set is those that are infinite but countable. So you know the positive integer. This, even though it looks like it's less, like it's smaller than set, it actually have the same cardinality, which is weird, right? Also, we have Q, set of rational numbers. So anything in the form A and B, B is not zero, and AB are in set. This is also the same cardinality. And if you choose only the even numbers, like even positive integers, right? This also looks like it should be smaller than n, but no, it's the same cardinality. So countably infinite is a bit counterintuitive, but essentially is anything that can be mapped with one-to-one onto function onto n. Those, any set that can be mapped one-to-one onto with n, gonna be classified as countably infinite. So they're gonna be in this equivalent class of set. Okay, you can find out more about cardinality from some source material, I'm sure. So that is it for this question. Thank you.